Well, now my dear, once again, let's start with the next topic, and the topic is total internal reflection. This is again a very important topic for the exam or board point of view, and the question is define or explain TIR, total internal reflection. We call in short TIR. Right, condition for total internal reflection. There is a condition. This is not happening at any moment. There is a condition. And third, what is the relation? You have to derive the relation which is used for the numerical point of view. What is the relation between refractive index, that is mu, and one concept you will go to study here, that is critical angle for given pair of media. You know refractive index, you will study new concept here, critical angle for given pair of media. Critical angle. So the concept is of critical angle is new to you all for this topic. Critical angle. So my dear, let's start with the topic. What is total internal reflection? And I will tell the condition also. So let me tell you the condition first to discuss with the topic. Let me tell you the condition first. So only you will understand. So my dear, here I am writing the condition first, or here I am writing the condition. Condition for TIR, that is total internal reflection. And what is the condition? The first condition is that light ray must travel from denser medium. Light ray must travel from denser medium to rarer medium. Light ray must travel from denser medium to rarer medium. This is the first condition, my dear. It means the TIR you will never see when it will travel from rarer to denser. You will see TIR, total internal reflection, when it will be travel from denser medium to rarer medium. That is one thing which is very important. Okay. Now, so let's start with this condition first. I am doing this condition first. So I am drawing the diagram. Let's start the diagram and see the diagram carefully. My dear, for example, here I have taken, this is the refracting surface. And I have given the name of the refracting surface as XY. You can see. And look at the terrific of this phenomena. The question is reflection. And I am drawing the refracting surface. So see that how from refraction, how from the term refraction, the term we are getting reflection. That is, earlier it will go refraction. And then from refraction, it will come into reflection. So look at the concept, how it is happening. So my dear, I have taken the refracting surface, and this refracting surface separate the two media, that is rarer medium and denser medium. So you can see this two medium here. And now my dear, assume that here is the object. Here is the object placed in the denser medium, you can see. Now my dear, for example, from object, say the ray of light is traveled. This is the denser medium. I said the light ray must travel from denser medium to rarer medium. So this is the ray of light from denser medium, my dear. It is traveling, and this ray of light is called incident ray. Incident ray. And here I have drawn the normal. Okay, this all you are knowing. So I am not doing anything new. Just look at the concept, what is happening. So I drawn the normal, and this is the angle of incidence. This is the angle of incidence, I. But my dear, what happened here, as soon as this ray is fall or incident on the surface, the light will be refracted like this. The light will be refracted like this. It is bending away from the normal. This is your refracted ray. Okay. This is one diagram I have drawn. Just look on drawing the diagram and look at what is happening. Here, my dear, before I go to concept, try to understand. My dear, this refracting surface which I have drawn, this refracting surface has a critical angle. They have the critical angle which for the given pair of media, this critical angle is there with the refracting surface. And what is the refracting surface? So refracting surface separate the two media. So my dear, there is a critical angle on the surface here, and this light ray incident and making an angle with the eye as a normal, with the normal. Now here in this case, my dear, you can see that the angle I is less than, I am writing here, less than, angle I is less than critical angle for pair of media. Matlab, what is happening? Sir, here angle of incidence which is made by this ray is less than the critical angle of this surface. Some kuch critical angle hoga. For example, the critical angle of this surface is 42 degree. For example, the critical angle for this pair of media which I have taken, a media will be depend, because as the media changes, the critical angle changes. Because critical angle is a concept for pair of media. So please take care of this. So for example, this incident ray which I have taken is making an angle of incidence I, because incident ray will make angle I. Assume that I is less than critical angle for pair of media. So yeah, there is some critical angle for pair of media. This I is less than that critical angle, and hence the light refracted. As the phenomena of light, it will refract, and it will refract away from the normal. No issues. Okay. Now let's go to the next diagram. Say again from object, the light is incident here. Now here also, my dear, I have drawn the normal. Here also it make angle I. Here also it make angle I, and let this time the angle I which is made, this incident angle which is made by this incident ray is equal to the critical angle for pair of media. Here the incident angle is equal to the critical angle for pair of media. So nice. Let I am writing this incident angle because this is second ray, let this is I1. But this time the incident angle is equal to critical angle, whatever be the critical angle, certain critical angle for the pair of media is there. So this angle of incident this time become equal to the critical angle for pair of media. What happened? This time the refracted ray will go like this. The refracted ray, this is the refracted ray. And it make an angle of 90 degree, you can see. It make an angle of 90 degree, my dear, this time. Earlier the refracted ray was this. But now the refracted ray in the rarer medium, because incident ray is in the denser medium. So refracted ray will of course in the other medium, because refraction tabhi hoga jab there will be two media. So if I taken the incident ray in the denser medium, no doubt this refracted ray I am drawing on the refracting surface, you can see, right? But this refracted ray is formed in the rarer medium. And how much is the angle by this refracted ray? 90 degree. And my dear, this time this incident angle which you can see here is called critical angle of incidence. So which angle of incidence is called critical angle of incidence? Sir, angle of incidence become critical angle of incidence. The angle of incidence in which medium? In the denser medium is become critical angle of incidence when it become critical angle of incidence? When the angle of refraction, or when the refracted ray makes 90 degree in the rarer medium, then that angle of incidence become critical angle of incidence. So now look at the third diagram, my dear. The third diagram is a complete final diagram. Say in the third diagram the ray go like this, and it will fall here on the surface. This is refracting surface. This time this will fall here. Say I am writing A point, B point, and here it is C point, and this is the normal. Now this incident ray which I am drawing here, the third one, at this time the angle of incidence I is greater. The angle of incidence I is greater than the critical angle for pair of media. And this time, my dear, the ray here is totally refracted back, is totally internally, you can see, is totally internally refracted back, and here it make an angle of refraction. Look at the diagram. So 1, 2 and 3. In my first diagram, my dear, once again look at an explanation, it's a beautiful. So first diagram, the angle of incidence is less than the critical angle for pair of media. See the diagram. The angle of incidence in the denser medium is less than the critical angle for pair of media, and the light will be refracted in the rarer medium as the phenomenon. In the second case, as soon as the incident angle become equal, the incident angle in the denser medium become equal to the critical angle for pair of media, because certain critical angle is always for any pair of media. So in this case, when the angle of incidence become equal to critical angle for pair of media, then what will happen? So the refracted ray will be in the rarer medium, no doubt. The refracted ray will be in the rarer medium. This is the diagram I have drawn. This is the refracted ray in the rarer medium, but this refracted ray will make 90 degree. That is, angle of refraction in this case become 90 degree. And this time the incident angle, जो अब तक हम incident angle बोल रहे थे, in the denser medium is now called as critical angle of incidence. And the last diagram, my dear, the third ray, where the incident ray in the denser medium, here again incident ray, this is in the denser medium, make an angle of incidence I, but this time the angle of incidence is greater than the critical angle for the pair of media. And if this is happen, then the entire ray of light, because previous case में light 90 degree पे आ चुका था refraction में, now the entire ray of light is totally internally reflected in the same denser medium. So this is the concept, my dear, and now I can tell you what is TIR, what is total internal reflection. And then here I am writing the second condition also. So you please pause the video for 2 minutes. If you wish to draw the diagram, please draw the diagram. First case I, that is answer angle of incidence in the denser medium less than the critical angle for pair of media. In second case, the angle of incidence in the denser medium is equal to the critical angle for pair of media, for which angle of refraction is 90 degree. And in third case, the angle of incidence in the denser medium is greater than the critical angle for the pair of media. And in that case, when it will be greater, then in that case, the total light will be internally reflected back in the same medium. So I will pause the video for 2 minutes. If you wish, you draw the diagram and then I will explain you what we have studied from the diagram. Thank you. So my dear, now let's proceed with the question that after explanation of this all, what is total internal reflection? And look at this third diagram. The third diagram, this one, O to C, OC. The OC will explain me what is TIR. OC. So now what is OC? You can see what is TIR. It is a phenomenon. It is a phenomenon in which angle of incidence you can see angle of incidence. Here I have written I. So simple. Look at the diagram, write the definition, write the question, answer very well. So it is a phenomena in which angle of incidence, where this angle of incidence takes place in the denser medium. So angle of incidence in the denser medium is, what is C? See the here symbol, greater. So there are two things. Sir, angle of incidence in where? In which medium? In the denser medium is greater than THAN, then comparing then the critical angle for given pair of media. Why I wrote the given? Because question wise the pair of media can different, and as the pair of media will change, the critical angle will change. So in that case, the angle of incidence should be greater, my dear, every time in the denser medium by the critical angle. It should be greater by whom? By the critical angle for given pair of media. So here is greater than the critical angle for given pair of media. The light ray is totally internally reflected. The light ray is totally internally reflected. So this is the phenomena, my dear, you can see, in which the angle of incidence, right? The angle of incidence in the denser medium should be greater, because this angle of incidence का form हो रहा है great denser medium में, should be greater than the critical angle for given pair of media, right? अगर ऐसा हुआ, then the light ray is totally internally reflected in the which medium, my dear? In the denser medium, because it is started from denser medium, and when it will be reflected, it will reflected in the denser medium. So the light ray is totally internally reflected in the denser medium. That's all. So main line is this only, this much, that it is a phenomena in which the angle of incidence in the denser medium is greater than the critical angle for given pair of media. This is the requirement. And that's, my dear, the first condition was that the light ray must travel from denser medium to rarer medium. And second condition, the definition which I have written is the second condition. The angle of incidence in the denser medium must be greater than THAN critical angle for a given pair of media. Such an important topic and such a nice topic. Look at the diagram carefully to understand the topic. Now my dear, after discussion of this all, that is TIR, condition of TIR and diagram. Now look at the question is, what is critical angle? Through my explanation, if you can see, what is critical angle? To whom we call a critical angle? Look at my diagram OB. Look at my figure OB. OB is the figure which explains the critical angle. My dear, what is the critical angle? Sir, critical angle is nothing but the angle of incidence. I have written I1. Here you can see I1 is equal to critical angle. So critical angle is nothing but angle of incidence. And this angle of incidence where I am forming? It is forming in a denser medium. You can see. So easy. You can see the diagram number 2, OB ray. In OB ray, I have written I1 is equal to critical angle. Matlab this time the angle of incidence which is making in denser medium, it become critical angle. Why I said it become critical angle? By looking the refraction is 90 degree. Jab the refraction is 90 degree, the refracting angle become 90 degree. In rarer medium, the refraction angle become 90 degree in rarer medium, my dear. Tab the angle of incidence in the denser medium become equal to the critical angle. And hence it is called critical angle of incidence. This time, this angle of incidence is not only simple name called angle of incidence. It is called as critical angle of incidence. So to whom we call critical angle of incidence? Critical angle of incidence is the angle of incidence. Critical angle of incidence, because this angle of incidence को ही critical angle of incidence बोला. But why this is called critical angle of incidence? This angle of incidence is not called critical angle. Why this angle of incidence called critical angle? Because angle of refraction in rarer medium is 90 degree. And therefore this angle of incidence in the denser medium is called critical angle of incidence. So my dear, what is critical angle? Sir, it is angle of incidence. So nice line. It is angle of incidence. It is not angle of refraction or anything. It is angle of incidence in the, इसलिए नाम पड़ा angle. It is angle ना. So it is which angle? It is angle of incidence in the denser medium, because incident ray is traveling in denser medium na? So the incident angle will made in denser medium. It is angle of incidence in the denser medium for which angle of refraction in rarer medium is 90 degree. It is angle of incidence in the denser medium for which, look at my diagram number 2, I become critical angle. I1 here in my diagram which is in denser medium become critical angle. So when this I become critical angle, that's what I have written. It is angle of incidence which become a critical angle in the denser medium. When the angle of refraction in the rarer medium, you can see In the rarer medium, this is a refracted ray I have drawn along the refracting surface only. So it make an angle of refraction of 90 degree. You can see in the figure. So for which the angle of refraction is 90 degree. Am I clear? In the rarer medium. I hope it is clear. It is denoted by, please denotation bhi dekh lo, denoted by IC. Because it is angle of incidence na. So now it is denoted by IC called critical angle of incidence. Called critical angle of incidence. I hope it is clear. Now my dear, now let's go to the relation. That is question number 4. That is relation between refractive index that is mu and critical angle. Now I have given the critical angle of incidence because critical angle now it's not only critical angle, क्योंकि अब तो डिस्कवरी हो गया, हमने डिस्कवरी किया. इट्स नॉट ओनली क्रिटिकल एंगल सर, इट इज क्रिटिकल एंगल ऑफ इंसिडेंस. बिकॉज कोई भी क्रिटिकल एंगल ऑफ इंसिडेंस है, कोई भी क्रिटिकल एंगल ऑफ इंसिडेंस है. इन विच मीडियम? डेंसर मीडियम. सो नाउ दिस इज नॉट ओनली क्रिटिकल एंगल, इसका कंप्लीट नाम हो गया क्रिटिकल एंगल ऑफ इंसिडेंस. सो क्रिटिकल एंगल ऑफ इंसिडेंस and denoted by IC. So we want the relation between mu and IC. That's the question. So now my dear, to solve this, let us take the Snell's law. You all know Snell's law. So by Snell's law, from figure. By Snell's law from figure. Now my question to you all, light traveling from where to where? Denser medium to rarer medium. Okay, denser to rarer. So let us take by Snell's law from figure. Let rarer medium is taken as medium 1. Denser medium is taken as medium 2. That is my supposition. You can say rarer medium as R also and denser medium as D also. But I assume the rarer medium as medium 1 and denser medium as medium 2. Second thing, let mu 1 is Ri of rarer medium, which is taken as say 1. I have taken it as 1 in value because rarer is lighter. Let it is air. Let it is air. So 100% it is 1. And let mu 2 be the Ri of denser medium, which is Ri of denser medium, which is taken as mu. It is taken as mu. So Ri of rarer medium, I assume the rarer medium as a air, for example. So Ri will be, of course, Chobesar, it is 1. But now if I take mu 2 as a Ri of denser medium, because second medium is a denser medium, I mention here. So if mu 2 be the Ri of denser medium, let mu 2 is taken as mu. So I hope this is clear. So now I am rubbing on this side and on the basis of this I am going here. So now what will happen? Look at it. I will pause after writing this and then I will rub this out. This side I am rubbing and I will continue this on this side. So now let's begin with the proof by using Snell's law. So by Snell's law from figure, and this is the figure I have already drawn. Now my dear, I have taken mu1 as a Ri of rarer medium. Say I have taken rarer as air, so it is 1. And let mu2 is taken as a Ri of denser medium and it is mu. Now my dear, by Snell's law you all know that the light is going from denser medium to rarer medium. Denser to rarer. So how will write this? It is going from denser. So जो medium से जाता है, that is written before mu, that is 2. And it is going in rarer, so it is 1 here. Right? I hope this much is clear. Now this can be written as mu1, or this can be written as what is the angle forming in medium 2? Because I told you the 2 here means the light coming from medium 2. So this is medium 2. And this is your medium 1. इसका RI is mu 1, it is equal to 1, and इसका RI is mu 2, that is equal to mu. Yeah, I have done all this in my supposition. So now the light going from medium 2, that is 2 to 1, right? So what angle is made in 2? What angle is made in medium 2? Sir, angle of incidence is made in medium 2. In medium 2, you can see angle of incidence, angle of incidence, angle of incidence in medium 2. So rule is that light जहाँ से आता है, that angle will be written in numerator. So it is coming from medium 2. Which angle is made in medium 2? Sir, I angle is made in medium 2. Which angle is made in medium 1? Sir, R angle is made in medium 1. So here it will be which angle is made in medium 2, that is written first because light coming from medium 2. So it is sin I divided by sin R. And you all know that this is 1 upon mu of medium 2 with respect to 1. 1 upon, I can write this now, because mu of 1 with respect to 2 can be written as 1 upon mu of 2 with respect to 1. That is by using principle of reversibility. I got this step. So earlier this step I got because of this Snell's law. By rule, मैंने पहले ही सिखाया, light जहाँ से आता है उसका angle will be in numerator. So light is coming from medium 2, angle will be I, because in medium 2 in my diagram you can see only angle I. Whereas in medium 1 the angle is R, right? Because incident angle made in 2 and angle of refraction is made in 1 because light travels from denser to rarer. But then I use the principle of reversibility. This mu of 1 with respect to 2 can be written as 1 upon mu of 2 with respect to 1. Now, so this is therefore from 1 I can write 1 upon mu of 2 with respect to 1 is equal to sin I by sin R. This is 1. Therefore, mu of 2 with respect to 1 becomes sin R upon sin I. I reciprocate it, and I will put this as equation number 2. Now my dear, you all know that, therefore, mu of 2 with respect to 1 can be written as mu 2 divided by mu 1, and this can be written as sin R divided by sin I, that is from 2. I have written into the mu of 2 with 1 is sin R by sin I. I have written mu of 2 with 1 is sin R by sin I, but mu of 2 with 1 can be written as mu 2 by mu 1. Now this will become, my dear, mu 2 is mu. Mu 2 is mu. So this is mu upon 1. Mu 1 is 1 because I assume rarer medium as a air. So this is 1 is equal to sin R upon sin I. Okay. And this can be written as Therefore, now, my dear, at I is equal to IC, when angle of incidence become, see, I have taught this, when angle of incidence, I is what? So normal angle of incidence, So an angle of incidence become equal to critical angle of incidence, when this I become equal to critical angle, that is critical angle, अब वो खाली critical angle नहीं रह गया, that angle of incidence become equal to critical angle of incidence, then your angle R is equal to 90 degree. This I got according to the definition of critical angle. ये बात मुझे कहाँ से पता चला? By the definition of critical angle. Sir, the definition of critical angle says critical angle is the critical angle of incidence. Yeah, critical angle is the angle of incidence. So I become IC. The normal angle of incidence become critical angle of incidence when R, that is angle of refraction in the rarer medium, is 90 degree. So here, what will happen? Therefore, mu by 1 can be written as mu is equal to sine 90 divided by sine IC. You can see. I hope you are getting me. And this is equal to 1 upon sine IC. Because you can see the sine 90 is 1. Therefore, I got the value, my dear, that mu is thus mu is equal to 1 upon sine IC. Or you can say sine IC is equal to 1 upon mu. Or you can say IC is equal to sine inverse 1 by mu. This is the formula, my dear. Mu is equal to 1 by sine IC, or sine IC is equal to 1 by mu, or IC is equal to, here it is sine, so IC is equal to sine inverse of 1 by mu. That's all over with the topic, my dear. I hope you all understood this topic very well. Thank you very much from my side, my dear. Jai Hind you all. And now tomorrow I will upload the 3 videos. One is the applications of TIR, total internal reflection. And then I will teach you a refraction through a single curved surface, that is convex surface and concave surface, followed by a lens maker equations. Thank you all, and Jai Hind from my side. Thank you very much.